Did you want to take any Q&A for Rock right now, or maybe afterwards?
I think we will do after. Right?
Yeah.
Yeah.
Okay.
We will conduct a session.
All right. Thanks.
So yeah.
Okay. Go ahead.
So thank you, Michał, and hello everyone. My name is Oskar Kwasniewski, and I'm a senior software engineer at Callstack. And as Michał mentioned, today I want to talk about the native feeling, which is something that applies to like every platform, no matter what. And yeah, we will discuss how you can make your app, a React Native app, feel truly native, and like what does it actually mean. So yeah, as I said, my name is Oskar, and I'm a React Native core contributor. I've created React Native for Vision OS and React Native bottom tabs and some other React Native libraries. You can find me on X and GitHub and also on LinkedIn. And so let's start by defining what's native. So we've got a native speaker, which is someone who learned the language from their birth. We've got a native cuisine, which is like a traditional food from a particular place. And China has some great food we tasted yesterday. And then we've got the native feeling. And we can define it as how closely the app's user experience aligns with the platform design patterns, behaviors, and interactions. And users of different platforms have different expectations. And then they expect your app to behave the way the other apps behave on the operating system. So, for example, iOS users, they are used to swipe to going back. And for example, Android users are used to clicking to go back, which is like a fundamentally different pattern of how this platform handles navigation. So if you create an app that doesn't do either of these things, let's say you create your own custom JavaScript navigation that doesn't respect the platform, your users might get a little annoyed that they have to change their patterns, how they use their phone, just for your app. So it's best to just fit in with how the native system behaves. And this might seem like a little detail, but it's actually extremely important. So next up, let's say users of tablets. They expect your app to fill in the whole screen, not just show a rectangle in the middle. And this is how Instagram was working for multiple years. They recently finally fixed it, so now the app is full screen. But yeah, also let's say TV users, they expect that UI elements should be focusable and they can be navigated with a remote controller. So in this presentation, I will try to answer this exact question: why native feeling matters in app development? And I hope at the end you will understand like what it actually means. So there is a paradox. You can build non-native feeling apps with native languages. So saying that if you want an app that feels native, just use SwiftUI or Jetpack Compose or something else is totally wrong in my opinion. And to prove that, let's play a small game. So in the next slide, I will show you a video, and your role is to closely look and identify which one is React Native. So let's start. Here's the option one. So take a closer look at like how the UI elements behave, the top bar, the tab bars on the bottom. So this is the option one. And here is option two. So this is the other app. And who thinks option one is React Native? So this is option one. Raise your hand if you think this is React Native. Okay. And option two, this is like a pretty similar app, but there are some subtle differences. So who thinks it's the option two is React Native? Okay, one vote. And yeah, the option one is React Native. It uses React Native bottom tabs, which is a library that exposes native bottom tabs, and also React Native screens for the top header. So yeah, this I think proves the point that technology doesn't matter as much as the user experience we offer. So let's address the most important question. Like, is React Native actually native? And even though some Twitter users and forums, they will argue that it's not native, that it renders just a web view, React Native is actually native. And it's built using C++, Kotlin, Java, Objective-C, and now more and more of Swift is coming in. And it's rendering the exact same views underneath as an app built with a native language for the operating system. So for Apple, it's using UIKit, and for Android, it's using Android views. Okay, so are there any rules we should follow to make it easier for us to fit into the system? So starting off with Apple, we've got Human Interface Guidelines, which is a comprehensive guide describing do's and don'ts of their platforms. So let's take a closer look. In one of the sections, they outline patterns for implementing navigation and search. So when you go into each section, they will give you a bunch of advices, like use a tab bar in this scenario, or use a header or a large header when it's the home page, and stuff like this. And they also include platform considerations. So iOS runs on like iPads, tvOS in some modified form. So all of this is included, and they guide you how to actually implement an app that feels native to their system. So let's look at the documents about tab bars. After the outlines, they have some best practices. For example, use tab bar to support navigation, not to provide actions, which I saw a lot of apps doing. Or don't disable or hide tab bar buttons even if their content is unavailable. And these are really helpful tips that you should apply to your apps. And there are also sections about iPad and tvOS. And visionOS in that case. And there's also a great page that tells you all about navigation bars and the navigation stack, and you can read more about it there. There's also a great page about presentation, outlining action sheets, alerts, scroll views, and more, so you don't overuse those patterns. On Google's site, we have pretty similar document, which is Google Materials Design. And indeed, they also tell you all about navigation with elements like navigation bar, bottom-up bar, drawer, and navigation rail. They also describe checkboxes and all sorts of other UI navigation elements that you should use instead of building your own. And when you get into each component, they tell you how you should use it and some best practices around it. For example, a bottom navigation bar should have at most 5 items, not more, because then it shouldn't scroll. It's just a bad UX experience. So I highly encourage you to go both through those 2 sites and read about what both operating systems have to offer. And this will make your app's UI and UX design a lot better. Okay, I see some people taking photos. Okay. So now that we know about the guidelines and components, how can we use them in our apps? So when you develop with native languages, it's easy. You can just import a native platform SDK, like from UIKit. You can import UI navigation controller or UI tab bar controller, and this will give you the tab bar. And the same goes for Android. You can just import material slider or something and use it directly. How about React Native? Like, we use JavaScript. We cannot import UIKit directly into JavaScript. Maybe if you use native script, you can. But it's a bit more complicated in React Native. So we have to depend on some third-party libraries. And thankfully, there are a lot of third-party libraries in the React Native ecosystem. And one of them is, of course, React Navigation, which combined with React Native screens exposes native navigation primitives that allows you to have native filling across your app's screens. And there are a bunch of other libraries exposing native components, and some of them actually many of them are developed by Oskar. You can check out reactnative.directory, which is a great resource for finding good libraries to use in your app. But what about the tabs? If you go into React Navigation website and look for the bottom tabs navigator, you would find that it looks exactly the same on both Android and iOS. And this is not what we saw in the interface guidelines from both Apple and Google, where the tab bars are completely different. And this is how the tab bars should look like on both iOS and Android. As you can see, they're not similar at all. And if we want to have natively filling up, this is like one of the most prominent components in some apps. So I thought, why through all of these years nobody created this? And maybe it's not possible, but now it is with like React Native bottom tabs. There's also now React Native screens implementation of bottom tabs. So this exposes the native tabs to React Native. And it supports like smooth navigation animations between the tab bars and views. And thanks to like being native to an operating system, it supports, for example, VisionOS, which you can see this like totally different appearance of the tab bar. So this is what we get when we use native primitives. It like automatically adjusts for a given operating system. And the same on macOS. It's just different. And the library is designed to be a drop-in replacement for JavaScript bottom tabs. So if you're already using JavaScript-based bottom tabs, you can just replace create bottom tab navigator with create native bottom tab navigator. And of course, there are some trade-off. Because the library is native, you can't pass a custom React element as a tab bar as you could with React Navigation JS-based solution. You have to pass an icon, which is a resource. But it can be an SVG or an SF symbol, which is also native to the Apple operating system. And one of the most requested features when actually introducing this library was being able to render a custom tab bar. So if we want to ignore everything I just said, you can also do it while gaining some performance improvements from actually using native underneath for switching the views. So let's see why native matters. As you can see in this example, we have like a floating YouTube window that just plays a video. So this feature is available in native iOS apps. So if you play a video in the background, the video will start to float. And with the JavaScript-based tabs, it doesn't ignore them, it just overlaps them. But as you can see with the native tabs, it doesn't want the video player to overlap the tabs. So your app is still perfectly usable even with the native video player on top of them. And this works because we are using the primitives provided by system from UIKit. And the same goes with Android, for example. There was this really nice feature, Material View, introduced by Google. And as you can see, if you change in the native settings of your phone the color system you prefer, so let's say you like orange, and then the app automatically adjusts to the preferred color that the user wants. And this level of system integration is only possible with native components. And the library supports both React Navigation and Expo Router. And I wrote 2 blog posts both for React Navigation and Expo, so you can read about it on those pages. So yeah, I highly encourage you to give this library a try. Here's a QR code for GitHub. You can scan it if you want. Okay, awesome. So let's move to another library that enhances your native feeling, which is Zigo by Fernando Rojo. And it exposes native menus for iOS, Android, and web. And you can find these menus all around the system. So You've probably seen this menu if you use iOS. Android has a similar menu that just shows a native pop-up. And yeah, this, as like iOS 26 is released, this totally changed the appearance. So if some framework relied on actually recreating this UI, now they will have to do it again. But with React Native, which is based on native primitives, as iOS 26 was released, it just changed its appearance automatically. And another big thing which many apps use is bottom sheets. You're probably familiar with GOSIM's bottom sheet, which is one of the most popular implementations of bottom sheets, and I think it's a great library. But if you want to have a fully native experience, it's probably not what you should be looking at. In one of the blog posts about native filling, Samuel from Buskai pointed out that they were running into issues with this bottom sheet library, mainly with accessibility, but not only. So they decided to create their own implementation of native bottom sheet. But there are other alternatives like React Native True Sheet or the ones provided by React Native Screens inside of React Navigation. So when you set a presentation of screen to form sheet or page sheet, you will get a similar appearance with a native filling bottom sheet. So let's move to another topic, animations, which are extremely important to make your app feel snappy and actually provide a nice user experience. And there are a lot of basic terms that people tell you every time they do a presentation about native filling, like always animate our 60 frames per second, or now with some devices, actually most devices being 120 frames per second, you should animate at 120 frames. Use reanimated or at least native driver in animated API that's built into React Native. Use interaction manager, which allows you to schedule a long-running operation after any interactions/animations finish, so you don't actually block the JS thread. But I want to bring your attention to another not so obvious topic. So let's say we have a button that executes this code. This will block the JavaScript thread for a pretty long time. And the user presses this button in the app, the do something button. And let's say the user now wants to, after pressing this button, they want to press the back button. So what do you think will happen? Option A, after pressing the go back button, but remember there's still this for loop for like 1 million going on in the background. Option A, user goes back. Option B, the app crashes. And option C, the app is stuck. So who thinks it's the option A? The user will just happily go back to the previous screen. Okay, option B, the app crashes. JavaScript cannot handle the loop for 1 million. And option C, app is stuck. Yeah, this is the case. App will be stuck because JavaScript thread will count to 1 million and execute console log. And we cannot do anything until the JavaScript thread is finished. So you have to be extremely careful with this kind of loops and doing long-running tasks on the main JavaScript thread, because this will block the interaction. And this is how the threads representation looks like at the moment of our do something. At the moment, our do something function is blocking the execution. So you can see on the JavaScript thread we have some other stuff, but then the do something function is actually continuously running on the JavaScript thread. And unfortunately, even though we use native navigation primitives like React Navigation, the event has to go through JavaScript to trigger and dispatch a navigate back event. So we could still, for example, scroll a scroll view as it's based on native primitives, but events that this scroll view would emit wouldn't come to the JavaScript thread until it's free to run some other tasks. So the main takeaway from this is that you should at all costs try to avoid blocking the JavaScript thread with long-running operations. and people opt in to use native libraries whenever possible. So, for example, if we have if we move this big for loop to the native side, we could spawn a new native thread, like this. So we could spawn a new native thread and execute this do something function under. So let's say this would be like a long-running operation. And this additional thread would execute its work and then, let's say, notify the JavaScript thread only after it finishes running. Most likely, you don't need this for most calculations, but it's good to know that there is a possibility to move something of the main JavaScript thread to a different one, because we can leverage the device capabilities of running multiple things at the same time. So let's do a quick recap. First of all, you should try to follow guidelines provided by platforms, either human interface guidelines or material design guidelines. You should use libraries exposing native UI elements and ensure that your app feels native on every platform, not only iOS, as many people do. So yeah, thank you.